So here's the problem. We've got a 30 amp motor that spins this fast, but we need our arm to spin this fast. We got a 350 watt motor. Let's mount it and see what it can do.
Oh no. Hi.
Yeah, welcome back. Long time no see. Did you miss us?
No.
And I didn't miss us either. Today we're gonna mount this big boy. We're gonna make a bracket for it, mount it. We're gonna get the pulley, stick it on there. That actually looks like it's gonna be simpler than we thought.
I like simple. So first thing, mountain motor.
Yeah, mount the motor. Let's do it.
We're good to go. Loud noises.
So in order to mount the motor, we decided to cut a piece off this steel plate, drill some holes in it, and bam! Made the plate for the new motor. 4 bolts sticking up. Mount the motor on top of that, bolt it down, ready to rock.
Boom. Motor in.
New motor, new pulleys meant we had to make a new belt. Smokin'! With the motor mounted, it's time for spin test number 1. We're gonna go ahead and start without the arm, see if we can hit 700 RPMs with the new motor. The first spin test with a 350 watt motor is going smooth. As expected though, there's no arm on this one. Easy first test, just to make sure everything's looking good. Spin test number 1 complete. Our goal was 700 RPMs. At 30% power, we hit 700 RPMs. Spin test number 1 being a success, we decided to go ahead and throw the arm on there and ramp it up for spin test numero dos. I feel like, because we're not going higher than like 170 something, but I feel like the motor's spinning faster.
RPM 177 at, what were we at?
40%,
40%.
It pushed over 200 at the end there, but I was getting closer to like 70-80%.
The belt just seemed to be a little, got a little janky looking there.
Yeah, I kept cranking it up and like I couldn't tell if like, holy shit, that's hot.
The motor? The spindle?
The spindle, it's slipping. It's 100% slipping.
Be careful. Oh,
It's very hot.
yeah, and so that's the side that looked like it was gonna come off.
I think this is going way faster than the belt is. And it's that friction is just heating this aluminum up. And that aluminum is hot. We're having a lot of slippage, which is heating up that pulley. We're gonna go ahead and tighten up that belt for another spin test. See if we can minimize some slippage.
Much tighter.
If it gets close, but it's still slipping, we can tighten it more. But if it's like not even close and it's slipping, then we'll probably have to switch to either a chain or some kind of different belt that's got more traction.
Might as well just go with the chain.
Okay, you ready?
Get my beer.
That way if something flies off, don't knock your beer over.
Exactly.
Starting spin test number 3 with an RPM goal of 450.
All right.
Power on.
Power on. Check for RPM sensor.
RPM sensor is working. We're at 6 RPMs, 30 RPM. All right, let's see how much slippage we got here. That belt looks way tighter.
Oh yeah.
Oh boy, yeah, it's picking up much quicker. I think it's transferring that power better. We at 160 at 20-something%, 170,
Oh, okay.
180. Oh yeah, we're at 30% at 200. 30% is 207.
Damn.
All right, let me know if anything looks bad and I'll kill it. We at 212.
I can't see any vibration going through the frame.
240.
I mean, pulleys are a little wonky, but that's just how they're gonna be.
Yeah, the pulley on the motor's a little wonky.
Just a tad.
The other pulley's pretty good. We're at 250.
I can feel the wind from that thing.
I think we're getting some slippage. The belt's coming loose. I'm gonna slow it down.
So we're at 255.
255.
Were we staying steady at 255, or did it take a little bit of?
It wasn't really increasing too much more. I could have given it more, but the belt actually, it's like getting wider. Initially, it's like tight on the pulley, like this. But as it gets faster and faster, this starts like getting spread out. So it's like ends up going like wide. It looks like this instead of being like really tight like that. It ends up being more like this. And it actually looks like it's like separating, like it's not making as much contact. It's actually further out. And then I think that's when it starts slipping. Of course, it got way faster before it starts slipping this time.
Way faster.
But that only hit 250.
Yeah.
unless the belt gets even tighter, we probably just want to go ahead and switch to like a chain or something that's not going to slip as easy, because this is slipping too much.
Yeah.
In order to get rid of the slippage issue, we're just going to switch to a chain, which is definitely not going to slip. So let's get these pulleys off, throw some sprockets on, and get after it. Nice. Good job. That's what I'm talking about. All right, cool.
Why that's so stressful for me?
Got it out. Now we're going to try to get this pulley off and put the new sprocket on. Good hitting.
Got it.
I think if you align it just right, it'll just go on its own, you know? Show me love tonight. Okay. Still spins nice.
Nice.
All right, we got the sprockets on. All tightened up, lined up as best we can. They're pretty close. So we're gonna put the chain on and see if we can get this thing spinning with chain and sprocket. It's time for spin test number 4 with an RPM goal of 700. Power on, motor on, start to slowly spin. Something's wrong. So at this point, the frustration is really starting to set in. Turns out, running a chain drive horizontally is just a recipe for disaster. Gravity actually makes the chain miss sprockets. If you run it vertically, gravity still has it aligned with the sprockets, but horizontally, you gotta run the chain tighter, the alignment has to be perfect. So we're done with the chain, just done. We've tried a round belt, we've tried a chain, now we're gonna move on to a cog belt, where honestly, we probably should have started. A cog belt won't slip like a round belt, and a cog belt is more flexible than a chain, so this should fix our slipping and our alignment issues all in one. Fingers crossed. Let's start spin test number 5 with an RPM goal of 700.
10%.
They're saying 10% is 300?
That's not 300.
Seems slow for 300.
Right?
I don't know. Try hitting 700 and then call it good. What percent?
720 at 30%.
Okay. Well, let's call it there. Let's put an arm on it. Starting spin test number 6 with an RPM goal of 450.
Test 1. 10%.
What an RPM is, I can't see on the
70, 80, 140. Seen anything funky?
No, it looks fine.
Pretty good to me. Crank that up to 30%. 180.
It seems like it's doing fine. It's just sketchy. What number are we at?
We're at 50% at 230.
Oh boy.
70%. We're at 260.
I don't want to run it for like an extended period of time.
I think we're gonna max out at 260.
What's that noise? Right there. Something's rubbing.
It's pretty consistent in the spot. Like right when the magnet passes the sensor. Yep.
It's one of the bearings or something?
It's the same spot every time.
The first cog belt test was promising, but there's this weird rubbing noise, and we gotta figure out what's grinding where. Huh. And voila! Now we've time traveled a couple hours into the future, and we feel like we fixed it. We took a bunch of stuff apart, we put it back together, it's now smooth, there's no rubbing noise in the bearings. We redid the mount for the motor, made it much more sturdy, and we cut the arm down shorter to the size it's actually gonna be. It was longer than it needed to be for testing, cut it down to where it's gonna be. Now we're really gonna see what the cog belt and new motor can do. Let's do spin test number 7 with an RPM goal of 450. Percent at 330 climbing. That's 50%. That's so sketchy. 50% at 392, 393. think? 70%? 450? We're going to bring that up to
50? 70?
Yeah.
I'm sure it was climbing.
Yeah, it was.
Okay.
Wait, is that the bottom coming up?
Yeah, I didn't look at it at that time because I was.
But I heard like ta-ta-ta-ta-ta-ta,
Yeah.
and I don't have.
I'm pretty sure it was that. Because that's whenever you hit about 60% is whenever I saw it. Whenever I looked the other time in the photo.
But yeah, we hit 65 miles an hour. You know? And we were climbing. We were only at 70%. It was climbing. I didn't stop because it was like it stopped. Usually that's what happens. We stop because it's like
Reaches a limit.
It reaches a limit. But
Yeah.
we stopped because our base is vibrating too much, and we don't want to throw stuff across the room. But yeah, we got plenty of time. This is a win. It's a huge win. That means we don't have to worry about this anymore. This is plenty strong.
Right.
We need to, reinforce this.
Yeah.
And then work on the rest of everything.
That's a win, for sure.
Man, we got it.
That's what we needed.
Nice.
Woo! Oh man, was that arm spinning? Oh, we could have hit faster. We hit around 65 miles an hour, which is plenty fast to test this. Ultimately, we want to hit a little faster later on, but that's good enough for now. We're going to have to go and reinforce that frame a little bit. It was vibrating. Get ye. From a motor and power transmission standpoint, that's a huge win. Move on to next episode, where we're going to be making the trigger mechanism. Thanks for stopping by. We'll see you next time in the Dusty Garage.
Bah.